Chapter 16, Lesson 1 begins our study on geometry on a sphere. Geometry on a sphere differs from geometry on a plane. Today, when we thought of a line, we think of 2 points to determine a line. And a line is straight and goes in opposite, infinitely, actually, in opposite directions. Not so with lines on a plane. Lines on a plane are curved, and they're called great circles. And this is an important concept. Every great circle on a sphere intersects another one. All right. So look at the definition on the bottom of page 690. It says a great circle of a sphere is a set of points that is the intersection of the sphere and a plane containing the center. So every great circle, if it were cut, if it were to cut the sphere, that great circle rather, would lie on a plane that goes through the center of the circle. So that's one difference, all right? The great circle would actually lie on a plane that would go through the center of the circle. But also, if you look at the lines on a sphere, they are circular. All right, they are not straight. Now, a couple of great circles that we're familiar with. One is the equator. It actually divides our Earth into 2 hemispheres. But also, if I were to cut the sphere in half at the equator, I would know that the plane that intersects this sphere would go through the center of the Earth. All right. Some other lines on our globe that we know are great circles are meridians. The meridians go from the North and South Pole, and actually would divide our Earth in half as well. All right. Now, the poles. The poles help us to think about the poles of our Earth. You know, we have a north and we have a south pole. And these are examples of antipodal points. And an antipodal point, it's 2 points of intersection of a sphere that would have a line through its center. So actually, if you can consider our Earth, if you considered our Earth and say this was the North Pole and this was the South Pole, you could draw a line straight through the Earth from the North Pole to the South Pole, and that line would go through the center of the Earth. All right, so a requirement for antipodal points would have to be where they intersect. If you drew them, a line through them, it would go through the center of the Earth. All right. Now, thinking about 2 points to determine a line. All right. Here I have line great circle M, and I have a great circle L. If we, for a moment, suppose that L and M are lines and not great circles, then, and going back to my definition of what a line is, right? 2 points determine a line, then I would have to say that A and B are not a line, do not make a line, because they lie at different points of intersection. However, A and B actually do represent points that would be on a line. They represent antipodal points. And they intersect at completely different parts of the globe, if you could see this as a 3D. All right, so A would be lying on the globe and B would be lying on the globe. There's a good picture of this on page 691. So if I were to say, so actually M and L are not lines. What is a line is what I can draw from A to B. So L and M are great circles. All right. Now, lines drawn on a sphere be parallel? Could I draw a line on the sphere that would be parallel to line L? And the answer is no. Why? Because every great circle intersects another one. Even if you go back to considering our globe, our lines of longitude, they all intersect at what point? The poles, right? And that would be the same with every line. Even if I tried to attempt to draw a line that was parallel to L, it doesn't. And also by definition, what makes lines parallel? They must lie in the same plane. This is not a plane. This is a sphere. Because remember, 3 non-collinear points determine a plane. And this is not a plane. All right? So, no line can be drawn on a sphere that is parallel to any other line, because on a sphere, every great circle intersects all the other great circles on a sphere. So some key problems for this lesson would be the beach ball problems on page 693. And I would know those and understand those. And that deals with the sum of the angles of a triangle. On a plane, it's 180. On a sphere, they don't equal 180.